In this video, we're going to talk about finding the minors and cofactors of a 3x3 matrix. Suppose we let A be a 3x3 matrix. Then the minor, M sub I sub j, of the element A sub I sub j, is the determinant if the matrix obtained by deleting the ith row and jth columns of A. In other words, we have a 3x3 matrix A where our first entry is A sub 1, 1 for the first row and first column. Then we have A 1, 2 and A 1, 3 for the first row and third column. In the second row we have A 2, 1, A 2, 2 and A 2, 3 for the second row and first, second, and third columns respectively. Then finally we have A 3, 1, A 3, 2 and A 3, 3. Now suppose you're asked to find M 3, 2. That's the minor for the third row and second column. So we block out our third row and second column and obtain the determinant of the remaining 2x2 matrix. So A 1, 1 times A 2, 3 minus A 2, 1 times A 1, 3. The cofactor C sub I sub j is given by C ij, or C sub I sub j, equal to negative 1 raised to the power of I plus j times the minor of I and j. Let's consider the following matrix A. And suppose I asked you to find the minor for row 2, column 3. We'll start by marking out row 2 and column 3, and then we'll take the determinant using the remaining values. So we have 3 times 5 minus 7 times 1. So our minor at row 2, column 3 is equal to 8. Now let's find the cofactor. So now we want the cofactor for row 2, column 3. And this would be obtained by taking negative 1 to the power of 2 plus 3 times the value of our minor. Negative 1 to the 2 plus 3 is negative 1 times 8. So the cofactor is negative 8. So there's a quick introduction on finding minors and cofactors of a 3x3 matrix. I hope you found it helpful, and we'll see you next time.